Hello guys, welcome to brainAttic. So today we have another very interesting problem from the topic of conic sections. This question was asked in JEE Advanced 2020. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So in this question, we are given that let a, b and lambda be real positive numbers. Now suppose p is an endpoint of the lattice rectum of the parabola y square is equal to 4 lambda x, and suppose the ellipse, the equation of ellipse is given to us x square by a square plus y square by b square is equal to 1, also passes through the point P. If the tangents to the parabola and the ellipse at the point P are perpendicular to each other, then the eccentricity of the ellipse is. It's a very simple question provided you know the formulas. Now, the equation of the parabola given to us, equation of parabola is y square is equal to 4 lambda x. Now, the endpoint of the lattice rectum. So, by formula, I can very easily write this formula is very popular. Endpoint of lattice rectum of y square is equal to 4 lambda x is it is defined by point P and its coordinates will be lambda comma 2 lambda. Now, point P also lies on the ellipse. Point P also lies on the ellipse, and the equation for the ellipse given to us is x square plus by a square plus y square by b square is equal to 1. Now we have found the coordinate for the point P. The next part of the question says that the tangent to the slope, tangent to the parabola and the ellipse at the point P are perpendicular. So now what we should do is we should go ahead and find the slope, because we know that if two lines are perpendicular to each other, then their slope, the product of their slope is equal to minus 1. Okay, so I should go ahead and find the slope. So y square is equal to 4 lambda x. So I'll do dy dx 2y is equal to 4 lambda. This 2 cuts it. So I have dy dx is equal to 2 lambda by y. Now I have to find the slope at the point P. So dy dx at point P is equal to 2 lambda by 2 lambda, which is equal to 1. So let me say that the slope for the tangent for 2 at the parabola be equal to m1, and we just found out to be 1. Same exercise I am going to repeat. X square by a square plus y square by b square is equal to 1. So 2x by a square plus 2y by b square dy dx is equal to 0. dy dx is equal to minus b square x by a square y. Correct? Now again this dy dx I have to find at the point P. So substituting the value, I will have b square lambda by a square 2 lambda, and this gives me b square by 2a square minus negative sign obviously. So this I'm going to say as m2. My m2 is equal to minus b square by 2a square. And just now I mentioned that if two lines are perpendicular, then their product of the slope should be equal to minus 1. So what I find is that obviously 1 into minus b square by 2a square is equal to minus 1, and this gives me that b is equal to root 2a. Now, very easy formula and very popular formula is the eccentricity of the ellipse, and the equation given to us is x square plus x square by a square plus y square by b square is equal to 1. So I can write this as E is equal to 1 minus a square by b square, which is equal to 1 minus half 1 by root 2, since I'm assuming b is greater than a. Okay, so the answer is option A. If you do like the video, hit the like button and subscribe to our channel for more content like this. Thank you so much for watching.